All right, today we're going to pick up with more hydrocarbons. This time we're going to focus on what they call unsaturated hydrocarbons. And if you think back when we talked about saturated hydrocarbons, we said that each carbon in that chain would have to be surrounded by 4 other atoms. When we get to alkenes and alkynes, alkynes contain at least 1 triple bond, and alkenes contain at least 1 double bond. You can have more than 1 in these compounds, but we'll just focus on the 1 right now. So because of that, if you think about the carbons double bonding, that's taking up a bonding site, and so there's not going to be the ability to have 4 atoms around each individual carbon. At least one of them will be what's called unsaturated. It'll have less than 4. So we'll start with our alkenes. Notice the ending is ENE. So when you see that ending, you know that you have at least 1 carbon-to-carbon double bond. The general formula for an alkene is that you double the number of carbons to get your number of hydrogens. If you look at the hybridization for the carbon-carbon on the double bond, it's going to be sp2. So let's say this is our example right here. We would fill in hydrogens. This can only take 1 more hydrogen, and then this one can take 3 hydrogens. So this would be C3H6. So if we wanted to name it 3 carbons, that would be prop. And since we have the double bond, it's just double, no double plus 2. This would be propene. So if we come in, let's grab a different color so we can look at it. If we come in and look at this carbon right here, he's bonded to 1, 2, 3 elements. So this one would be sp2 hybridized. If you look at the second carbon, he's also surrounded by 3 atoms. He would be sp2 hybridized. And if you look at the last carbon, he is surrounded by 4 atoms, so that would be sp3 hybridization. So sometimes you're going to be asked questions to discuss the hybridization, let's say of carbons in this compound, and you would want to go through each one and just look to see how many atoms are surrounding it, or how many really regions of electrons, so that you can come up with your hybridization. So this talked about the naming. You're going to use your same prefixes that we've used, meth, eth, prop, bute. And then the ending is going to be -ene. We need to let people know where that double bond is occurring, and so we're going to number the main chain so that we'll have the lowest number for the double bond. So if you're thinking about numbering, your double bond is more important than a branch. More important than a branch. So you need to number so that you get the lowest number on that double bond. So the first example we're going to do is ethene. So that would be C2H4. If we were to draw it out in expanded format, we would have C double bonded to C, and then an H coming off of both ends. And then to satisfy the octet, it would look like that. If we were going to write it condensed, we go section by section, and we would just say CH2, CH2. So again, the condensed is a little bit shorter, but you're still showing what's going on in the compound. And so hopefully if you were to look at that formula, you would know, oh, there's got to be a double bond in there, because otherwise those carbons are not satisfied. We can have geometrical isomers. So the isomers that we talked about with alkanes were called structural isomers. That's when they have the same chemical formula, but a different structure. These are geometrical isomers, and so if you think about shape, that's what these are talking about. So there's 2 different types. It's called cis and trans isomerization. So if you look at these 2 examples that they've given you, and this type of isomer only occurs dealing with the double bonds. And the double bond has to be within the chain, meaning that you don't have cis and trans isomers if the double bond is on that very end carbon. So if the double bond were here, or if the double bond were over here, you don't have cis and trans, because we're going to look at what it means to be cis and trans. So if you think about the fact that these are, kind of zigzaggy chains of hydrocarbons, if you look for this double bond, the hydrogens are coming off the same side. And then if you look at this one, you see the hydrogen, one is coming down and one is coming up. And so with alkanes, we don't really worry about this because the whole thing rotates. But if you remember what a double bond means, a double bond consists of a sigma bond but it also has one pi bond. And so what ends up happening is you've got the pi bond that's actually stabilizing this bond, and it makes it rigid. So it loses the flexibility that alkanes have. So if this is a rigid bond and a rigid structure, these can't rotate. So cis and trans will have different properties. So if you've heard of like trans fats in the news, when you look at the trans, you'll see that the H's straddle the double bond. So a way to remember it, if the H's are on the same side, that's called cis isomerization. And if you think of like sisters, sisters are usually close. So one way you can remember it is, oh, they're on the same side, it's cis. Trans is when they're straddling the double bond. One is on either side. And if you think of like a transcontinental railroad connecting things that are, apart from each other, that's one way to remember it. So sometimes you won't be given a structure you could tell. Like if we had written this condensed wise, we would have said CH3, CH2, CH2, CH3. And you really can't tell, is it, on the same side of the double bond or is it straddling it? So if they don't show you a structure where you can tell, then you just don't worry about saying what it is. So we'll practice these. We'll look at some straight chain alkenes as well as some branched. And if you look at A, you'll notice the double bond, so we know we're dealing with an alkene. And the way they've drawn it, you can actually tell if it's cis or trans. So remember that you've got these guys on the same side of the double bond, and this is fixed because of that pi bond overlap. So we've got 1, 2, 3, 4 carbons. So we know that this is butene. And then we need to let people know, well, where is the double bond happening? And so if I number it left to right or right to left, I get the same combination. So this would be 2-butene. And since the H's are on the same side, we would put cis out in front. So this is cis-2-butene. They also want us to write the expanded and the line notation, which is the condensed. So if we do that for the line notation, we would have line, line, line. And so that gives us 4. And if you look at this structure, is that what it looks like? This doesn't match, right? So you'll sometimes see boat notation. They call it boat. And so if we were going to draw it, we would want to draw it how it really looks. And so we've got that there. We've got this sitting like a boat, and then this coming up. And so we need to draw in that double bond so that they can see it. So this would be the line notation for cis-2-butene. We'll probably look at trans. I believe I give a trans example later so that we can show it. And then if you're going to draw the expanded, we'll do that for this one, and then we probably won't do it for others, just so you can see. It's just making it kind of longhand. So we've got the H's coming off the same side. And again, you could have put these both up or both down. It doesn't matter. And then these coming off that way. All right, in B, we've got an alkene, but we've got some branches as well. When you're finding the main chain does have to include the branch. So if I go this way, I could call that my main chain. That would leave this as a branch and this as a branch. So I'm going to number from right to left because I want to give that double bond the lowest carbon number possible. All right, so we've got 5, and it does contain a double bond, so this is going to be pentene. The double bond is occurring on the first carbon, so we'll call it 1-pentene. You could also call it N-pentene, which is normal pentene, which means the double bond is occurring at the first carbon. And then we can't tell if it's cis or trans, and really, since this carbon double bond is occurring on the first carbon, we wouldn't even have cis or trans, because this would have 2 hydrogens coming off of it. All right, dealing with our branches, we've got a branch at the third and a branch at the fourth. So we would say 3, 4, just like we did before, 2 methyl groups is going to be dimethyl. So 3,4-dimethyl-1-pentene. If we were going to sketch it out, we have 1, 2, 3, 4, 5. So there's my main chain. Coming off the fourth, we have a branch. Coming off the third, we have a branch. And then we would show the double bond right there. So that's your line notation. All right, this last one, find the chain. All right, that makes this a branch. Be careful not to circle those H's because those are not branches. But what is it trying to show? You've got H coming up off one and down off the left. So this is cis or trans. If they're on opposite sides, think Transcontinental Railroad. So this is trans. To number it, I'm going to go 1, 2, 3, 4, 5. So still pentene. And you do where the double bond starts. So it starts on that second carbon. So trans 2 pentene. And then we've got a branch coming off the fourth. So we would say 4 methyl trans 2 pentene. Short notation, we've got 1, 2, 3, 4. So we're showing it this way. There's our double bond. So we've got 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. And coming off the fourth, we have this branch. So notice how the line notation looks different. You can tell from line notation. So if we're going to compare this one to this one, right? This is why they call it boat notation, because it looks like a boat that's floating. And this is more on the zigzag. And so this is your trans, what it'll look like in line notation, and that's your cis. All right. They've given me line notation, and they want to know, let's see, the expanded and condensed and naming it. So I think the easiest thing, and I don't know if this will help, this usually helps me, is if I come through and I count my carbons. So I've got 1, 2, 3, 4, 5, 6. I see a double bond, so I know it's going to be hexene. And looking at this, does it look like the boat? The H is coming off, or does it look like trans? And if you look, the H's are coming off this way, right? So this is cis isomerization, and the double bond is occurring on the second. So we would say 2-hexene, put the cis out in front, and we don't have any branches coming off of that. So cis 2-hexene. Here we've got 1, 2, 3, 4, 5, 6, but we do have a branch, and we have trans isomerization. So this is trans, double bond is occurring at the second, so trans 2-hexene, and then coming off the fourth carbon, we have a methyl group, shown by the one line. And I'm going to skip doing the expanded, just to save time on the screencast. All right, you can have what are called dienes, and so it sounds like you're saying dying, but you're really not dying. It just means that there are 2 double bonds, and so they call those dienes. So the di kind of gets squashed in the middle, and so you could have like butadiene or hexadiene, which means it's hexene and it has 2 double bonds. So you need to let people know where the double bond is occurring. You typically don't have to worry about cis or trans with this. You do get cis or trans isomers, but it's not something that you're going to have to worry about in this course. So here we have a 4 carbon with 2 double bonds, and so you'll notice it doesn't really matter which way I number it, left to right, right to left, but you do want to count where the double bonds are beginning. So if I number going this way, there's a double bond beginning at the 1 carbon and a double bond beginning at the 3 carbon. So I would say 1, 3, and this is methprop-bute, so that instead of being just butene, it's butadiene. So see how we kind of smush it in the middle? So we kind of add the A back in, because if it was just a 4 carbon double bonded, it would just be butene, but you kind of put the A back in there. All right, and then here we've got a 3 carbon. So if it just had 1 double bond, it would be propene, but because we have 2 double bonds, we're going to say propadiene, and it's occurring at the first and the second carbon. So it would be 1, 2 propadiene. So I hope that was helpful. Here's your practice, and then tomorrow we'll go over those answers and see how they went.